go. So what I wanted to start out with today was to give you a real application. And if you notice in your book, they have word problems in there. I've not been assigning them to you because everybody in here knows those are made up word problems. Somebody kind of did it so that it fits right inside your textbook and you have a solution in the back of the book. Unless somebody thinks there's some real problem that people are working on, I'm going to tell you the truth. They're totally fake. I wanted to give you a real problem to think about, where people actually do use trig. And today we're actually going to learn how to solve this problem as part of the lecture. But I'd like to motivate it with an example, and then I'd actually like to try it out in class. I have no idea what's going to happen from this, if it's going to work or not. One of the physics professors helped me think about how we can make it work. So when there's a blood splatter analysis, moving away from the microphone, and when there's a blood splatter analysis, the way that it works, you see, how many of you watched Dexter? Okay, so in Dexter they have all the strings coming up where they're trying to pinpoint the location of where the person actually committed the crime or how tall they were. All this can be done with just what you're learning in class right now. So the idea is the following. You have a blood droplet. Pretend that it's in slow motion, going to hit the floor. What happens is it's going to hit the ground and then it's going to fall. When it falls, you can actually estimate this line right here by looking at how wide the blood droplet is on the ground. So this line right here can be measured, that once the blood droplet hits the ground, you can just take a ruler and actually look at that length. So this value you will have. The other value, this value over here, from B to C, you will have too. How can you get this value B to C? Imagine this blood spot hit the ground and fell. What part of the blood spot would be this portion right here? Where could you get that from? Our estimate of it. Picture this thing sliding through this little tube and then that's where it hits. What would this length be in relevance to this blood drop? That's right. You could just take a ruler and measure that length of the blood drop and that gives you this side right here. And these are rough estimates. That's the real world. The real world's messy. And there's a lot of assumptions here, right? That when it hit the ground, it matters what the ground was formed of. Like I have wooden floors. Believe me, sometimes I do want to actually kill the kids, but I haven't done it yet. If it hits the wood floors, it might, when they don't want to eat certain foods and you made dinner, it's hard. My apron on. So if it hits the floor and it's a wooden floor, it'll be different if it hit the floor and it was this floor. So the way it hits the floor actually matters. So we're only getting a rough estimate, and that's probably the best we can do. So once it hits the ground, what you're going to get, you have this side and this side. And you would like to know where that drop came from. So the drop already happened. You're walking in the room. The drop's on the floor. You get these measurements. What you would like to know is the direction that came from. And that's how you pinpoint where the location of that blood drop came from. You need that angle. Right? So we haven't done anything with calculating angles. We've actually calculated sine of angles. So what you need to do is back calculate. So you're going to reverse the process to identify what that angle is. And the thing that you use is something called the arc sine. That's the reverse of the sine. So you want to undo the sine. How do you find, what's the relationship in a triangle when you have the sine of an angle? The sine of an angle in a triangle is equal to, in a right triangle. The sine of an angle is equal to, when you have a right triangle, opposite over hypotenuse. So you have a relationship. So once you have that relationship, the missing thing that you're looking for is actually you have the opposite. You don't have the hypotenuse, but you have this side. You know how to get the hypotenuse from Pythagorean theorem, right? Once you have that, you have sine of angle is equal to a number. Now you back calculate and figure out what that angle is. So let me show you what that looks like. They actually have, it's not possible, when they never show you in Dexter people sitting around with notebooks and protractors and figuring this out. They actually have kind of a catalog that they'll look up and say, okay, I know what this angle is. If the drop hits straight down, which we're going to do in class today and actually measure, you're going to get a droplet that it gives you an angle of 90 degrees. You can kind of, if you're really good at geometry, you can see that picture. If it went straight down, it wouldn't be angling at all. It would just go straight down like this. So that would be a 90-degree drop. If the more oblong it gets, what you see here is that the degrees go up. We're going to use degrees today because we actually want to measure it in some kind of framework that we know what the angle is. So 18 degrees makes some kind of sense to me of where to actually put my string. So if you have a bunch of blood splatter, the way that they do this in Dexter is they measure out all of the angles for each one of these things, and they string for each one of the blood spots, and then they string up directly on the edge of the blood spot. They string up a string, and where all the strings connect is the source of the impact. So they're really back calculating and figuring out where the source of the impact is by just stringing along these angles. Does it make sense? These ideas that you learn in class, they're just, they seem like you're learning the recipe, but no one told you what you're making. You're just getting one recipe after the other, and there's no rhyme or reason for what you're doing. But when it is in a real application like this, not a fake one from your book, but a real one, it should make sense. It should make obvious sense of what you're doing. So I'm going to go through how they do this. The first thing that you want to do is you want to calculate the width of the blood spot. And it's laying on the ground. You can actually look at the oblong shape and just take a ruler, which I forgot to bring down for you guys. I have printed out rulers for you. We're actually going to do this and see what happens. So I showed you on the blood droplet what they're representing. Say it was 1 centimeter, for example. I don't know, I was trying to think how big a blood spot could be. Then you want to calculate the height of that blood spot, just like we talked about earlier. That length right there is equal to, I made a black line right across. So if the blood droplet is laying on the floor, you can actually measure that with a ruler and see how long it is. Let's say, for example, it was 3 centimeters. I put some fake numbers in there just to give you, the long side is going to be always longer than the short side, right? So I'm going to put 3 centimeters there. Step 3 is to calculate the hypotenuse. That's the thing that's laying on the bottom. I can do that. Here, it's the real world. There's no WebAssign that's asking you for the exact answer. You need to know kind of where that number is. So you use decimals to approximate it. And I've saved myself by putting little wiggly lines, letting me know that it's an approximation. That's because I'm a mathematician and I'm crazy and I have to have equals means it's exactly equals, and the approximate equals means it's approximate. Most real normal people will just put an exact equals. So I know that side. Now I need to find the angle. Well, the angle is opposite over a hypotenuse, right? Sine of the angle is opposite over hypotenuse. And the opposite is 1 centimeter, and the hypotenuse is around 3.16. So I can plug that in. How do I get, let me try this, it's so awkward. How do I get this angle over here? Well, the angle, just like when you undo a square root, you square both sides, it's the inverse of the sine. It doesn't mean it's 1 over sine, it's the actual back calculation of the sine. So, for example, if I have sine pi over 4 equals square root of 2 over 2, which it does, if I'm given square root of 2 over 2, I can back calculate and tell you that the angle it came from was pi over 4. So that's the sine inverse of square root of 2 over 2. You're just going backwards. Make sense? Okay, so you're undoing it. So I can actually solve for it. I don't have to figure out on a circle or anything. I can just go to my calculator. And I should have looked up a TI. I don't know what they look like on the TI. If it's sine with a -1 to the top, or if it's a sine. Sometimes they put arc sine. Look on your calculator and tell me what you got. Sine to the -1? So you can try it out. I think I put mine in degree mode. Yeah, I put it in degrees because this is a real problem. I can get really involved with pi, but I also can get, if I'm doing a real measurement, I'll probably use degrees because I want to use an approximation of where, I know what 18 degrees kind of means. 9 degrees is flat up, 18 degrees is 45 degrees is halfway between, it's lower than 45 degrees. So I have kind of a way to estimate approximately that angle in my head. So see if you get 18 degrees too. You have to put your calculator into into a degree mode to get that. So try it out. You take 1 over 3.16 on your calculator. And actually, I think on the TIs you type sine inverse, and it has a parenthesis there. Put sine inverse with a parenthesis. You put this number in the parenthesis. You close. I don't think you even need to close the parenthesis, right? Back in my day, we had to close the parenthesis. So you can just hit enter, I think. Give you about 18 degrees. That's cool, right? We'll try this. I don't know, who didn't do their homework? No, we won't use the real blood. That just shows how nuts you think I am. That just told me right there. You think I'm completely crazy. So I can guarantee I was the only professor that came to class today with a bottle of ketchup. And I was probably the only professor that came to class with a spoon. Let's do something. We're gonna have to stand up. I need your help. We're gonna move the desks aside so that we can do some measurements. I'm gonna bring down the protractors and the rulers so you can do it. What I'm gonna do is I thought of ways that I could do this. Even though I work out, I don't think I'm strong enough to burst a balloon and make it splatter all over the place. And I probably have to go over to the gym and shower afterwards, so I didn't want to do that. But I think what I'll do is I'll take a spoon and just do a couple drops. So I'll do one that's straight down and ask you to actually measure the length and the width and see that you get 90 degrees. It should be, we already know the answer. And I'll try to make it so that it goes a little bit further out. I'll make a couple droplets, and I just want you guys to go through, and as a group, each of you can pick one of the droplets and measure them out, length and width, and do the back calculation. So let's get a spoon. Is it good enough to leave it right here? You remember where the 1 centimeter and 3 centimeter came from? Who doesn't remember it? One more time? Because I want to leave it on one screen. Okay. The 1 centimeter comes from measuring across. Okay. The 3 centimeters that I made up these numbers, right, comes from this. So the 1 centimeter represents this, which is the distance across. The 3 centimeters represents this, which is the width, the length. So you can use that from the blood spot itself. And then this would be the missing angle, so you know that sine of, you need to actually calculate the hypotenuse. So you do that by 1 squared plus 3 squared and the square rooting it. Square root of 10. And then once you have that, you have this, so you'll get this number. So you know sine of that angle is opposite over hypotenuse, and then you back calculate the angle by inversing the sine. Go to your calculator. Got it? Most fun you ever had in PreCalc? Let's push the desk aside. You guys push the desk aside, I'll run upstairs.